And so in that lecture video just now, got a head start on this, which is today's lecture worksheet 6.2. So this is writing the half reactions will help us figure out in a redox situation, which is what's going on in batteries, what is losing electrons and what is gaining electrons. And so let's scroll down. So already looked at this part. And let's try these examples. So the goal is to identify what is oxidized and what is reduced. So there's a few things that are review, which is understanding a balanced equation and then differentiating that now you're looking at two half reactions. So you need to figure out those half reactions by, let's see, going back to here, you have writing those two half reactions. And then by looking at where the electrons are, either on the right side, the products, or on the left side, the reactants, that will tell you if it is the oxidation half reaction or the reduction half reaction. So that's what that says. So let's take a look at this process on this example. You want to follow the fate of this is iron and zinc. Okay, now these are already listed as ions, so we don't have to figure out any ions for this. So, but you want to follow the fate. So this is Fe, that is iron. On one side, on the left side, it's Fe. And on the other side, you have Fe2 plus. Okay, so what this means is looking at the charges, you have a 0 for Fe that has no plus or minus. And this, you can write an equal sign for the arrow, but on the other side, you have a +2. Okay, that's what that 2 plus is. It's a +2 ion. So those charges are not equal. The only way to make them equal is to add -2. So this is +2 on here. And then if you add a -2, so plus a -2, -2 plus 2, that will make it equal to 0. So what I did was I wrote plus a -2. And then when you do that, what that means is you are adding 2 electrons or 2 electrons that each have a -1 charge to that side. Okay. And so what that means is that when you have electrons on the, oops, I want that in red. When you have electrons on the product side, so on the right side, that's the product side. That's electrons that are lost, and that's the oxidation half reaction. Okay, so that's what this says up here. When you have the element that's oxidized loses electrons, the electrons are on the product side. So let's take a look at the other zinc. So zinc, following the fate of zinc, you have Zn2 plus on the left side. So Zn2 plus is on the left side of this arrow. Then on the other side of the arrow is just Zn. So the charges, looking at the charge values, you have a +2 on the left side. And for the arrow, you can write an equal sign. On the right side, you have no charge value on the Zn. So in order to make this equal on both sides, well, it's +2 on one side and 0 on the other side. Actually, I'm going to make a little bit more space here. So this is Zn, so it's 0 on this side. So to make this equal, you have to do the same thing where you have got to have adding a -2 on this side, on the left side, because +2 minus 2 is the only way to get to 0. You can only add electrons to one side. And that's in order to balance your charges. That's what I was doing there. So I added it to this side here, and I'm adding it to the other side in order to balance the charges and make this 0, +2 minus 2. So I'm going to add 2 electrons on that side of the zinc half reaction. So when you have electrons are on the left, that's the reactant side. Well, that's the definition of a reduction half reaction. Okay, so that's what you're doing is you are figuring out your two half reactions. And that is by following the fate of one element. So I just looked at the iron, or I just looked at the zinc. And then you got to look at which side the electrons are on to figure out if it's oxidation or reduction. Okay, so for number 2, for the next one, this is another level up where you are not given the ions. So you need to figure out the ions, or specifically the charge values. So when you have an element alone, such as the examples which are H2 and O2, well, these are no charges. So no charge value or 0. So this hydrogen is a 0. It's not an ionic compound. So the hydrogen atom has a 0 charge value. Same thing for oxygen in O2. It's not an ionic compound. So that oxygen atom has a 0 charge value. But when you have the ionic compound or the compound H2O, you need to figure out what the individual charges are. So you need to determine the charges by splitting these. I called it the reverse of the crossover rule. So you take the element symbols and you split them apart. So you have to determine the charges by splitting this apart. So you have H separated from O. So write H separated from O, put a plus and a minus. Okay. Why did I write plus and minus? Because when you have a compound that's ionic, the positive charge is always first. And then I'm going to pick up this 2. It's a subscript. When I'm picking it up, I'm not picking it straight up. It is going to be the reverse of the crossover rule. So it has to pick up and go cross over. So it's going to cross over here and become the charge value on the oxygen. So what it is, a subscript here becomes a superscript. That's the reverse of the crossover rule. And so this is the charge value for hydrogen is +1, and the charge value for oxygen is usually -2, because hydrogen is in family 1A and those form +1 ions, and oxygen is in family 6A and those form -2 ions. So what you have now are some charges you can list below this. Let me erase that. So below the hydrogen is a +1. Come on, pen. Let's try this. Okay. No. Come on, pen. Let's try this. Okay. Okay, there we go. The hydrogen is a +1 and the oxygen is a -2. So once you figured out the ions, then you want to follow the fate. Hydrogen goes from 0 to +1. And so from 0 to +1 means that, so it's 0 on this side, +1 on this side, means that you have to add the charges. They're not equal. So this is a 0, and this is not equal to +1. To make this equal, you have to add 1 electron. Okay, so whoops, let me write that differently. You have to add a -1 charge. So -1 + 1. So that means I'm adding 1 electron. Okay, and so this is the hydrogen, which was H2, becomes this part of H2O plus 1 electron. Okay, and so when you have the electrons on the product side, so this is the example of the oxidation half reaction. Okay, and so in this oxidation half reaction, the thing that is oxidized is the hydrogen. H2 is what is oxidized. This, okay, and it's only the reactants on the balanced equation, H2 or O2, that are the things that are going to be oxidized or reduced. Never anything on the product side can be oxidized or reduced. Let's follow the fate of the oxygen. So oxygen is O2, and it becomes oxygen in H2O. So looking at the charges are that you have a 0 on the O2 and you have a -2 on this side. So H2O, the oxygen was -2. Well, those are not equal. So in order to make those equal, you've got to add electrons somewhere. So adding electrons would have to be on this side. So adding a -2 on the left side. So that's adding 2 electrons here on the left side. And this is -2 will equal -2. Okay, they don't always equal 0, but you do want to make sure the charges are equal on both sides by adding electrons. And so what you have is electrons are now here. When you have electrons on the reactant side, that's electrons on the left side, that's a reduction half reaction. And so for the reduction half reaction, this is that the thing that is reduced is this, the oxygen, the O2. The O2 is reduced. Okay, so specifically O2, not oxygen in H2O, or not oxygen, just the oxygen atom, but specifically O2, what is in the reactant side on the primary reaction. Okay, and let's take a look at this one, which is aluminum, iron, and chlorine. So we want to follow the fate of all of these, but we first have to figure out the charge values if you have a compound. So when you have the element alone, this aluminum is 0. That's an element alone. It's not bonded to anything else. Same thing with this iron. Fe on the right side, that's an element alone. The charge value is 0. So for these, the FeCl2 and the AlCl3, those are both ionic compounds, and you want to figure out the charge values of each atom in there. So you split this apart. FeCl2, you split apart into the element symbols Fe and Cl, and then you write a plus and a minus. And that becomes a 2 that picks up. So this 2 right here picks up and becomes the charge value on Fe. And so this means that this is a +2 ion and a -1 ion. And you can write the charge values right below these. Okay. And so AlCl3, this ionic compound, you want to write the element symbols and split them apart. So write Al separate from Cl, put a plus and a minus, and then this subscript 3 becomes a superscript. You pick it up and it's a 3 +3 charge there, which means that this is a +3 charge on Al and a -1 charge on Cl. And so this is the charge values are going to allow us to follow the fates for aluminum and for iron and for chlorine. So when you have aluminum, this goes from 0 on the left side to +3 on the right side. Okay. When you have iron, this goes from +2 on the left side and then 0 on the right side. And then chlorine is -1 on the left side and -1 on the right side. So only 2 of the elements have changes going on. So aluminum goes from 0 to +3 and iron goes from +2 to 0. So this is figuring out what's going on here is in order to have this equal 0 and +3, you're going to have to add a -3. So add a -3 to this side of the aluminum. So what that means is this is going to look like this. It's Al goes to Al +3 +3 electrons. This iron, this is +2 is not equal to 0. So you're going to have to add -2 on the left side here. And this is +2 -2 will then be equal to 0. And so the way this looks is that you have Fe +2 coming from here, +2 electrons. And then this is Fe on the right side. Now there are some coefficients. So notice these coefficients, I'll underline the 2, the 3, and the 2, and the other 3. I didn't pay attention to any of those coefficients and I didn't write any of those coefficients because we're really not needing to look at the coefficients. Those are for balancing the equation, where now we're focusing on the charges. Okay. And so when you write those 2 half reactions, the two half reactions will show you the electrons on the right side. Electrons on the right side, that's the product side. This is the oxidation half reaction. And so for the oxidation half reaction, you go back to the original equation and you see the aluminum in the original equation is the thing that is in the reactants. So aluminum is what is oxidized. And then the iron, and specifically the iron that is in this, okay, so that is the FeCl2. This is the reduction half reaction is the other one. And it's the reduction half reaction because you have that 2 electrons on the left side, on the reactant side. And so when you have the reduction half reaction, which is part of this iron, this is iron, but it's not just Fe, it is FeCl2 that is in the original reactant of this entire equation. So that's FeCl2 is what is reduced. And so that's a little different when you have the iron that is in something, it's in the compound FeCl2, the entire compound, the entire chemical formula for the compound is what you write for the reduction, what is reduced. Okay, so let's pause what's called a galvanic cell. So this is the same thing that you just saw, which is 2 beakers. So you've got 2 beakers, one side is an oxidation half reaction and the other side is a reduction half reaction. And so you also have given here the 2 half reactions. So we can actually start by looking at these 2 half reactions, which are here, this copper and this silver. So you have copper and silver, and you can see you have copper on one side and silver on the other side. Those are the element symbols, Cu and Ag. So this half reaction, notice the electrons. Where are they? If they're on the right side, that is on the product side, and that means that it is the oxidation half reaction. The electrons are lost. This other half reaction with the silver, the electrons, that 1 E minus, the electrons are on the left side. That's the reactant side. That means electrons are gained, and that's the reduction half reaction. The mnemonic oil rig, oxidation is loss, reduction is gain. Okay, and gain means electrons on the reactant side, they go in, and loss means electrons on the product side, they go out. And so when you have the oxidation half reactions identified, then you know that these electrons are lost. And so what you can see here now on the diagram is that this is copper solid. And you have solid copper where there's an arrow coming out of it. That means these electrons are lost. That E minus is showing these electrons are lost and they're flowing through this wire and they're flowing through this voltmeter. So you have electrons going through the voltmeter and that measures the volts. Okay, so that's the symbol V. That's electrical output. And then they continue on through and these electrons then are gained here. They go into this other side and they're gained by this silver electrode. So you have a copper electrode and you have a silver electrode, that's Ag. And then this continues on as a full circuit where you have ions flowing through this salt bridge. Okay, so what do you have here? Let's answer some questions. In which beaker is the oxidation occurring? Well, that's the left side, which is the copper. The beaker, the beaker with the copper in it. Okay. The reduction is the reduction half reaction. That's the right side. And so that reduction half reaction has the silver in it. So that's the copper electrode. That's Cu. Electrode, that's Cu. And that's the silver electrode. That's on the right side. That's the Ag. Okay. So writing the oxidation half reaction, that's just copying this. Cu goes to Cu2 plus 2 electrons. And then the reduction half reaction, that's copying that one. That's Ag plus 1 E minus goes to Ag. That's these 2 half reactions. So what exactly is losing electrons? It's that copper the Cu in this half reaction, this one, is what's losing electrons. It's on the left side of the arrow and it's losing the electrons. So what that is actually the copper, solid copper electrode. Okay, so the solid copper is what's losing the electrons, this one here. What is gaining electrons though? So what's gaining electrons is this in red. So this Ag plus ion is what's gaining electrons. So going back up here, you can see this Ag plus is gaining electrons, and it basically then incorporates into and becomes part of this silver cathode. And that's how the pictures that I showed you at the end of that last video, one metal is lost and another metal kind of is a little bit larger after these redox reactions. So that's the silver ions in the beaker. So the silver ions in this beaker, the Ag plus, are what are gaining those electrons, not this Ag, not the Ag solid cathode. Okay, so the anode versus cathode. So the anode is the thing that is the electrode that is on the oxidation, electrode on the oxidation side. So what's the electrode on the oxidation side? That's the solid copper, the solid Cu, or the copper electrode. Okay, and so the cathode is the electrode that is on the reduction side. So going back up to the diagram, this is the reduction side, the reduction half reaction. So the electrode in the reduction side is that silver, that Ag. So that is the solid Ag, the silver electrode. So that's what the anode and the cathode are. They always have to be a solid piece of metal. The purpose of the voltmeter is to measure the voltage, the volts or the voltage. And then the purpose of the salt bridge is to close the circuit. And that allows ions to flow through. Actually ions and charges to flow. And so that is the equivalent of an on-off switch, is when you basically remove a salt bridge or you have a circuit that's not closed. So this beaker has to have a flow through above it in the voltmeter, but then also below that, you have a constant flow, a closed circle. So it's a big circle that's kind of more like a U shape. Let me draw this in red. So you have electrons lost here, going through the voltmeter, going into the silver electrode, and then continuing on, they have to go through the salt bridge and come back around to make a full circle. Okay.
Could I see the bottom, please?
Mm-hmm.
Thank you.
Now I'm going to paste in the last two videos. I'm going to copy in the last two videos, which are types of cars. So these are types of cars. Many of you guys said you want to purchase a more efficient vehicle in order to reduce your impact. Well, there's so many options out there now. There's hybrid, there's plug-in hybrid, there's electric, there's hydrogen. And so I have two videos for you, which you will see as Quizlet questions. And so those videos are actually pasted directly, copied directly into the questions themselves. So, but I'm going to copy the, I'm going to copy the two video links. They're two videos and they are types of cars. And I promise you by the end of it, you'll be like, okay, I get it. I know I need to watch these. They're both another 15 minutes when you watch both of them. So get to those since you guys stayed. Yay. Thank you for sticking around. And you guys will be able to access the recording later too. So that's what I have for today. If you have any questions, you can stay a little bit. I also have appointments from 1 to 3 today.
Thank you.
Okay.
Thank you, Professor.
Thank you.
Professor, I have a question.
Yes.
Are you still taking the bingo or
I
is
am. I am.
okay,
Yeah.
perfect.
There's only 3 people have it in, so it's up
Perfect.
to, yeah.
Thank you so much. Have a good
Okay.
day.